Corporate finance practice problem using Excel. Expected value and net present value, even yearly cash flows. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet, would like to follow along, note that we are in the practice tab as opposed to the example tab. The example tab in essence being an answer key. Information on the left-hand side, we're going to populate that into the blue area on the right-hand side, applying then out our analysis that we've been looking at into the future, and then a net present value calculation as well. So this is another type of scenario. We've seen this kind of analysis to think about how we can group things and make decisions into the future, and now we have another kind of scenario that we can put that into place with. So we're going to imagine a situation with a capital budgeting type situation where we have that initial investment of the $15,500. The life is going to be 5 years. We're imagining in this situation then we're going to have even inflows from this investment. We don't know what those inflows are, but we're going to imagine for the next 5 years, for 5 years out, that this piece of equipment will have even inflows as we go through the next 5 years. So then we're going to apply our statistical kind of thought process to this. Now, in the past, note we've done these capital budgeting type of decisions, matching different kind of decision options, making assumptions about what is going to happen in terms of cash flow into the future. Obviously, those are assumptions. So this will help us, this framework can kind of help us to make possibly some of those assumptions that we can then use to be comparing with other type of capital projects. All this stuff, of course, is happening into the future. We don't really know what's going on. We can just basically group our thought process in the best way we can to make as logical a decision or prediction into the future that we can. So note, if you're looking at a situation like this, there's basically two ways that we can use our analysis down here. We got these different categories that we're going to work these into and our probabilities to help us group the information in our mind. If we were to think of this capital budgeting type of situation as having even cash inflows, these options then, whether they be good, not good, so on, representing even cash flows for the next 5 years, this would be in the annual cash flow, then we can basically use that and do our probability calculation, and then the result, the expected value, the expected annual return, then we can use and calculate our net present value using that amount. However, if we have a situation, the other way we could do this is we could basically calculate the net present value for each of these, imagining these happening, net present value in each of them 5 years out, and then taking the net present value calculations and applying basically our probability kind of calculation based on that, which we might do in a future presentation. Now, note that the first method that we'll do now, we could only do if we assumed even cash flows into the future. If there were uneven cash flows into the future, then we couldn't do this method. We would have to do the present value of the cash flows and then apply this kind of thought process on the net present value, which we might do in a future presentation. So we're gonna assume here that we have then the possibilities, and you don't really need the possibilities over here, but I'm just gonna list them in words just so we can have some categories. So not good, okay, good, very good. The numbers, of course, are what's going to be important. Where would we get these numbers? Based on prior performance, possibly other like equipment, possibly other companies doing similar types of things, trying to estimate what their possible returns are from it, and then projections out into the future. Again, we don't know exactly. Our goal is to put this into a framework where we can get our mind working in such a way that we can make some predictions, hopefully in as logical a way as possible. So we're going to say 4,500, 6,000, 8,500, 10,000. Those are the inflows per year for the next 5 years that we are assuming. So then we want to say, let's assign some probabilities and then get to our expected inflow for the next 5 year based on that. So we're going to say the first one, 20% likelihood, then the second one, 30%, third one, 30%, fourth one is the 20%. If we sum that up, then we get to 100%, of course. Then we can calculate our expected value, which would be the 4,500 times the 20%, the 6,000 times the 30%, the 8,500 times the 30%, the 10,000 times the 20%, summing that up with the equals SUM, shift 9, and sum it on up. Font group and then underline. So there's going to be what we assume to be our cash flow. So now we're assuming that to be our yearly cash flow for the life of this equipment of the 5 years. Then we can use that to do our net present value calculation and possibly use that to then compare against other projects. So we can then say, let's do our calculation up top, 0, 1, 2, 3, 4, 5 years. I'm going to center those items by going to the alignment and center. Cash flows, we're going to say outflow negative 1,005 or 15.5, and then it's going to be equal to our expected value of the 7,250, which is our annual cash flow. So we'll bring that on down. You might say, hey, look, that's an annuity. Why don't we use the annuity calculation? We can. I'll do that later. We'll do it with the annuity too. So let's drag this on down, and this is going to be the total. Now, the fact that these are even, that's what I'm talking about with regards to these being even. If these were not even cash flows, these options not representing even cash flows, then we might have to do this net present value first for each of the options, and then maybe we can use those in results to do a framework like this, which we might look at in a future presentation. All right, let's do our present value calculation. Negative present value, shift 9. I'm going to go through this fairly quickly because we've done a lot of these in prior presentations. If you want more detail on them, go back to those prior presentations. So I'm going to pick up the rate, which is going to be our cost of capital down here, and I'm going to make that an absolute reference. F4 on the keyboard, $sign before the B and the 13, comma. Number of periods is 0, which means we're going to get to the same result here, but then I'll be able to copy it down, comma, comma, because it's not an annuity, but present value of 1. We'll do an annuity shortly. And that's going to be the 15.5. We come up to the same number because we're at period 0, but let's copy that down, putting our cursor on the fill handle and dragging fill handle down. Then if I double click on one down here, it does look like it's doing what it's supposed to do. So that's good. And font group and underline, and let's sum it up. Summing it up. So then we get the 9,390. Which we can then say, well, that cleared 0. That's above 0, so it cleared the rate of the 14%. So you can see how we can imagine this to happen, because again, we don't know what these numbers are. We could do this outcome, and we could net present value each one of these 4 outcomes, like we say, and then try to do some kind of statistical analysis. But the bottom line is we got to get to some number here that we can then compare possibly to other projects. So this is one format that we can frame our thought process in order to do that. We can see here that based on this analysis, we've cleared the 14%. What rate are we at? What if we wanted to compare this to other returns or other projects or other equipment that is clearing the hurdle rate of the 14%? Well, we can calculate the IRR, which is equal to the IRR, shift 9. And then I just pick up this flow. And we then get to the 37.13. That's pretty good, it seems like. That's the rate at which this net present value based on these cash flows would be 0. And then just note that we could calculate this with an annuity calculation, which I kind of like this calculation if you have Excel. Annuity calculations are often what's going to be done in book problems because they're trying to lower the amount of calculations if they take away your calculator and whatnot. But in practice, it's kind of nice to have, each of the yearly flows. So Excel really has a better representation, I think, in that format. But test questions have a different objective, right? They're trying to test you on stuff. So if you're calculating or getting ready for a test, they might limit you for other reasons. So the annuity, then let's do the annuity type of calculation. This would be the negative present value, shift 9. The rate would be the 14%. And again, we have presentations on how to do the annuity with a formula and how to do it with tables if they make you use tables in prior sections. You can take a look at those there. I won't go into a lot of detail here with that. Number of periods we're going to then say is 5. And this time it's an annuity. So we're just going to say the annuity or is the payment, which is going to be that 7,250. 7,250. And then we had the initial investment. So the investment, which was equal to, I'm going to say negative of the 15.5. And that's going to give us the total, which is going to be equal to the sum, S-U-M, of the 9. Let's do that again. Equals S-U-M. Shouldn't it be positive? I must have put it in. Yeah, so there it is. So we can calculate it that way too. So anytime you see a series of payments that are the same, you might think annuity, but just realize that, of course, you can do either one. It's not like, these two things are related, of course. So, but again, in a test question, they're more likely if they make all the payments the same and take away your calculator and give you tables or something to do an annuity calculation. But you can see how this same method here basically can be applied to different things when we're trying to structure our thought process in the future and we don't know what's going to happen, right? And we're trying to put this stuff together in such a way that we can come up to a prediction. Then here's our prediction, and you can imagine a situation where there's large capital projects and you're competing with other people that all have their own personal interests on the capital projects, and the numbers, you're trying to come up with numbers that are predictive into the future here, and it's all predictions that are taking place, of course, but you're trying to make them as accurate as possible so that you can kind of compare these things out, right? So we got our prediction on the annual values, then we got to do the present value, and if we're competing with other kind of projects or there's other projects we're deciding on, then we might take the internal rate of return if we can only pick some projects and not the other. And again, you can see how all of this is an attempt to be as scientific as possible about an approach, even though we don't know because we're looking out into the future.